All right, so Reach for the Top is a math contest that goes on every year in Canada, and they sell T-shirts at the shindig to raise some money. So let's suppose that the people running the contest purchase the T-shirts in advance. Okay, so they pay $7.50 for each T-shirt that they want to sell. Right, they have to buy them from the supplier. Plus $125 in fixed costs. That could be things like shipping and processing, and maybe they wanted a certain logo on the T-shirt, so they have to pay for that as well. Okay, so they pay a flat fee of $125 and then $7.50 per shirt. After they purchase the shirts, they sell them at the events for $12 each. Okay, so they make a profit of about $4.50 per shirt. Okay, so we're going to write two equations. One to represent the total cost. There should be no M there. That's a typo. Okay, so the total cost C as a function of N, the number of shirts. All right, so what would that look like? C of N equals 125 plus 750, right? This is how much it costs to buy N number of shirts.
750 N.
Okay. And then the revenue as a function of the number of shirts sold. This is money coming in. How would you model that function?
12 N.
12N, right? There's just $12. Sorry, I should use R, not C anymore. R of N equals 12N. Okay? So we've got one function that represents how much the organizers of the event have to pay for N number of shirts, and another function that represents how much money they bring in based on the number of shirts that they sell. Okay? Graph these two functions on your calculator. All right, so let's graph these two functions. Go into y equals, and we'll first graph C of N, so 125 plus 7.5 N, but we got to use X since we're using the calculator. And then R of N was 12X or 12N. Okay. Let's choose some window settings. Let's make the X max go to, I don't know, let's try 50. And then the Y max, let's go up to about 500 and see how that looks. Okay, there we go. There's a nice view of our graph. So the top line right here is the cost, how much it costs to purchase N number of shirts. And then the bottom line is revenue. As they're selling more shirts, more money is coming in, right? Let's talk about this intersection point right here. Okay, so to find that intersection point, we go second, trace. Number 5 says intersect, so we're going to press 5. And then enter, enter, enter. We'll find that intersection point. What would that point mean in context of the problem? Well, it would be the point at which the amount of money you're spending, the cost, to buy the shirts equals the amount of money coming in, right? We call that the break-even point. After that point, the revenue, this line right here, begins to become greater than the cost. And at that point, you start making a profit, right? Originally, if you don't sell more than, what is this? If you don't sell more than approximately 28 shirts at the event there, you're not going to really make any money, right? You want to sell more than 28 if you want to make a profit, and if you want all of that effort that you went through to buy all of those t-shirts actually be worth it. Can you write me the equation of the function p of x equals r minus c of x? What would that look like? P of x equals r minus c of x. How would I get that function? What would it look like? Yeah, right. I'm taking r and subtracting c to create a new function, a new equation, right? So I take r of n. I should use n, not x here. It should be n, and that should be n. So I'm taking R of n and minusing C of n to create P of n. Okay, so R of n was 12n, C of n was 125 plus 7.5n, and then I just combine like terms, right? 12n minus 125 minus 7.5. That's equal to 4.5n minus 125. So that is P of n. And what does that function represent?
It represents...
No, Tobias. Good.
The total profit.
Yep, profit. Right, try to give you a hint with the P. Okay, so this function alone models how much profit they make given the number of shirts that they sell. And again, you can kind of guess what the x-intercept of this equation would be, right? When do they start making profit? How many shirts do they have to sell? About 28, right? So that's when this function would start to get above the x-axis, right? Initially, if n was 0, or they sold no shirts, you would have negative $125, which makes sense because you have to pay $125 to start with, and if you don't sell any shirts, you don't make any money, but you have to pay the fixed costs, okay? And then as you sell more shirts, you get profit from there.